Hello everyone, in today's lesson we are going to look at how to add and subtract complex numbers on a complex plane and obtain the principal argument of the resultant complex number. Now on our screen we have a question. If w equal to 3 plus 5i and z equal to 3 minus 2i, find part A z plus w, part B principal argument of z plus w. Now we are going to start by representing each of the complex numbers as vectors. Reason being, these complex numbers specify their direction from the origin. Now if I start from the origin, I'm going to move 3 units along the positive row axis and then 5 units parallel to the imaginary axis but perpendicular to the real axis, implying that if I connect the arrow from the origin up to a point where we find W, we shall specify the direction like that. Okay. Now, if we consider Z is moving 3 units along the positive real axis and then 2 units downward. Therefore, if we draw an arrow connecting the origin to Z, we shall have it like that, where its tail at the origin and its head at a point 3, negative 2. But now we are interested in obtaining Z plus W. What does that mean? We are going to add the units of W onto the head of Z. Okay, so to add it, we are going to move. Remember that our W is given by 3 plus 5i, meaning that we are going to move 3 steps along the positive real axis and then 5 steps upwards. Okay, so this is one step, the second step, and the third. From there, we move 5 units upwards, which is 1, 2, 3, 4, and then 5. Okay, meaning that we need to draw an arrow connecting the first dot and then the last dot. And it is very clear that this arrow is parallel to this arrow. Now, if we want to obtain Z plus W, remember that this is our W. Now, if we want to obtain Z plus W, we just connect the origin up to the head of W, like that. Okay, so let's obtain W plus Z. So meaning that Z plus W equal to, we have moved 1, 2, 3, 4, 5, 6 units along the positive real axis and then 1, 2, 3 units along the imaginary axis. And by the way, it is very clear that by addition of complex numbers, if I have Z plus W, this is equal to 3 plus 5i, then plus 3 minus 2i. We said that when we are adding complex numbers, we add the real parts onto real parts and then imaginary parts onto imaginary parts. So if we try to add, we shall have something of that kind. And 3 plus 3, this is a 6, plus 5 minus 2, that is a 3i, which is the same as our answer using graphical method or geometrical method. Now remember that they want us to find the principal argument of Z plus W. Now in order to do that, we have to first extract out the right angled triangle. So we draw it here. Where this is the principal argument. Theta. So I put it here. Now from here up to here, there are 3 units. So I put them there. And from here up to here, this is 6 units. But remember, if we have our right angled triangle like that, a theta here and the opposite, when we have the adjacent, we are going to use trigonometry to obtain the value of theta. So we are going to say tan of an angle theta is equal to the opposite, which is a 3, out of the adjacent, which is a 6. Therefore, theta is equal to tan inverse of 3 out of a 6. And if we place our calculator, the value of theta is equal to 26.6 degrees in an anticlockwise direction. Example number 2. Z is equal to negative 2 plus 3i and W equal to 3 plus 6i. Find Z minus W and its principal argument. Now the first thing to do is to first locate Z and W on the Argand diagram. Now it is very clear that Z is equal to negative 2 plus 3i, implying that from the origin we are going to move 2 steps backwards and then 3 steps upwards. So this is the origin and these are the 2 units, then 1, 2, and then 3 steps. Okay, this is our Z. So we connect Z to the origin simply because this is Z specifies its direction from the origin. Now when we consider W, for W we are going to move 3 steps in the positive real axis and then 6 steps upwards. So this is 1, 2, 3 steps, and then we move 1 step, the second, the third, the 4th, the 5th, and then the 6th. So this is our W. So we connect W to the origin using an arrow because this complex number W specifies its direction from the origin. Now our interest is to obtain Z minus W, but we are going to say Z minus W. This is the same as saying Z plus the reverse of W, implying that if our W is equal to 3 plus 6i, its reverse is going to be equal to negative 3 minus 6i. So we are going to start from the head of Z, moving 3 steps backwards along the real axis and then 6 steps downwards along the imaginary axis. So this is 1, 2, 3. Okay, then we move 1 step, the second, the third, the 4th, the 5th, and then the 6th. Okay, so we connect using an arrow. Okay, by the way, it is very clear that this arrow is parallel to this, but instead this one moves in the negative direction. Now let us obtain Z minus W, and in order to achieve that, we are going to connect the origin up to the last dot. Okay, so we are going to say Z minus W is equal to 1, 2, 3, 4, 5 units backwards along the real axis, and then 1, 2, 3 units downwards the imaginary axis. Okay, so now we need to obtain the principal argument of Z minus W, and in order to achieve that, we are going to draw our right angled triangle. Okay, and we cannot take this angle as our principal argument. Reason being, this angle is past 180 degrees. Therefore, we are going to take this angle instead, which is theta. So when we extract out our right angled triangle, beautiful it is, like this. Okay. The angle here is 90 degrees. So we are going to take alpha here. Okay. So this is 3 units and now this is 5 units. Okay. So we have the opposite of the angle alpha and the adjacent, implying that by use of trig we shall say tan of alpha is equal to opposite out of adjacent. Therefore, alpha is equal to arctan of 3 out of 5. Let's get our calc and obtain the value of alpha. So alpha is equal to 30.96. But now also remember that this alpha is not our principal argument. Alpha just enables us to obtain our principal argument. So we are going to say theta is equal to negative 180 degrees minus 30.96 degrees. I'm taking a negative, reason being I'm starting from the positive real axis, moving in a clockwise direction. And when we measure angles in a clockwise direction, we must apply a negative. Therefore, theta is equal to 149.04 degrees in a clockwise direction. Thank you for watching. Don't forget to subscribe, like and share the video for more about math.